All right, so looking at some of these chain rule multi-derivative problems, specifically, hey, let's take the second derivative of a chain rule problem, and that would be number 3 from WebAssign that you guys had most recently. That's a tough problem, and there's a lot of layers that go into it. So I'm going to try and break it down as much as I can and color code it, and maybe give you a strategy for tackling these that might be a little more organized. So first off, when you take the derivative and do the chain rule, that's for those of you who got this down. There you go. There's the derivative using the chain rule. But the parts, the way this happens, if you remember, you really have to identify what the inside of the function is. Our chain rule problems are pretty much exclusively going to be these parenthetical function, something in parentheses, to a power, maybe a multiplier, some constant multiplier out front. And so it looks something like this usually. Well, the inside's important because when you're taking the derivative, you think of taking the derivative of the outside with the inside untouched times the derivative of the inside. Those are the components of taking the derivative with a chain rule. So the yellow parts you see there, those are the outside derivative of the outside. It's the power rule. You notice the 3 came out front times the 5, and the power went down by 1 degree. The inside stayed untouched, and then right next to it in parentheses on the end is the derivative of that inside, 2x plus 2. So that is the chain rule. So no big deal. If I said first derivative, do the chain rule, really I'd just say simplify to at least this much, if not more. If we're going to take a second derivative and go on, or even more, you've got to simplify. And we did this in class too, but it's so important. So I would suggest at the very least, distribute that 15 to the 2x plus 2 and write this function here. And then say, all right, let's take another derivative. That's what a second derivative is. Just take a second derivative after the first. The problem is we have now a product rule and a chain rule. The right-hand function, x squared plus 2x all to the second power, that's going to require chain rule. The first one, 30x plus 30, no big deal. But together, they're multiplied functions, so we're going to have to do the product rule. So let's set up let's set the stage for a product rule. Do a little template here. So second derivative. Here's my product rule spaces. Now when you do product rule, you have to have a first function and a second function identified here. And then what you're going to do is you have 4 little components. You take the derivative of the first times the second unchanged, plus the derivative of the second times the first unchanged. The parentheses there for those particular operations. Let's break this up a little bit more. So let's do the derivatives of the first and the second function. Let's just get them out of the way. You know, the derivative of the first function is 30. The derivative of the second function, a chain rule, a little more complicated, but we did one before, very similar, right above. So it's 2 out front, x squared plus 2x, and then times the derivative of the inside, 2x plus 2. So those are our derivatives. Now the big mistake that usually happens with this chain rule is that you take the derivative of one and multiply it times the derivative of the other. Boy, I wish it worked that way, but it doesn't. So you actually have to split it up where you take the derivative of the first and the second separately on either side of that plus sign. So you do the derivative of the first, but you multiply that times the second unchanged. So here's just indicators. I want to know that you take the derivative of the first and the second, no doubt, but that's not the whole thing in a product rule. You have to put them in their proper place within that product rule. Then the derivative of then the other 2 pieces are just the other function untouched. So good old product rule is derivative of the first, that's the 30 you see there in red, times the second unchanged, plus the derivative of the second, that's the green function you see there, times the first unchanged. That's your product rule. It so happens when you're taking the derivative of the second, it was a chain rule. Sometimes the second function requires a quotient rule. You might have your own special derivative rule that you're applying when you're taking the derivative of the first or the second. But all I know is that I set up the template for the product rule. Derivative of the first times the second unchanged, plus the derivative of the second times the first unchanged. I set the space up for those, and then go about putting the parts, either the derivative or the original function, in the proper place. And voila, there's your derivative. You just leave it as is. For this purpose, since I'm not going on, I'm not asking you to plug in any value. I'm just saying get the derivative. This works just fine, and so you could stop here. All other things, nothing more complicated than this. This is definitely the high end of things for what we're going to need to do from here on. Please email with questions.